Hi guys, Math 1513, College Algebra at Northern Oklahoma College, Chapter 2, Section 3. I'm going to show you how to graph an equation by rewriting the equation in slope-intercept form. Okay, you guys remember slope-intercept form. So the whole idea on this section is to change an equation that's all messed up back into slope-intercept form. Remember, why do we call it slope-intercept form? Because when you write it in this order, with the y on the left side of the equal sign, and the x term on the right side of the equal sign, and then have a number hanging around out there on the end, that number in front of the x is your slope, and the number hanging around out there on the end is your y-intercept. That's why we do it, because this makes it super easy to graph. Alright, so if you're given something like x minus y equals 4, and they tell you to graph that by rewriting it in slope-intercept form. Well, what's the important thing about slope-intercept form? The y is alone. The y is isolated. It's by itself on that side of the equal sign. So that's what we're going to do here. We're going to get this y alone, which means we have to get rid of that x. Now, how do I get rid of that x? Think about that x as a positive x. It's positive. Think about positive as plus. So think about that as a plus x. To get rid of it, I'm going to minus x. Okay? Remember, you have your fence here. I want to get the y alone on that side of the fence. So minus x from both sides of the fence. My x is gone. Here I have not just a y, but I have a negative y. Don't forget, wherever that y goes, that negative goes with it. On the left side, I have 4 minus x, but I would rather write it as negative x plus 4, because I want it to look more like our y equals mx plus b up here. So all I did was I moved the x up here, but I remembered that the x was negative, so I brought the negative with it. And I moved the 4 back here, but I remembered that the 4 was positive, so I made it a plus 4. So I didn't change the meaning of the equation. I still have my negative y in front. Okay, how many y's do you see there? I see one y. It happens to be a negative 1, but there is one y there. So there's a 1 there that we don't write, because mathematicians are lazy and we don't want to write anything we don't have to. So there's an understood 1 there, negative 1. How do I get rid of negative 1 times y? I divide that negative 1 off. And if I divide that by negative 1, I have to divide everybody by negative 1. And I end up with y equals, now negative divided by negative is a positive, so that's really a positive x over 1, or just a positive x. And a positive 4 divided by a negative 1 is a negative 4, or a minus 4, same thing. So I end up with y equals x minus 4. Let me show you a quicker way. I'll show you a little trick here. So I start out with x minus y equals 4. Well, a little trick is when you move stuff to the other side of the fence, see that red fence I drew there on the equal sign? If I move a term over to the other side, it changes sign. Like notice my y over here, it was a negative y. Well, hang on, sorry, I didn't move that. I moved the x. Notice the x there. When I moved the x, it became a negative x. So when it jumps to the other side of the fence, its sign changes. So what I'm going to do is I'm going to use that little trick, that little knowledge, and I'm going to move that negative y over to the other side of the fence, where it becomes positive y. And I still have a 4 there. It's a positive 4, so I write plus 4. And here's what I got right now, x equals y plus 4. Now I'm going to use that trick again. Remember, I want the y to be alone. I'm going to use that trick again, and I'm going to move the positive 4. I'm going to make it jump across the fence, and now it's a negative 4. And I have my equation, y equals x minus 4. Now the y is on the right side of the fence, but that's no big deal. It doesn't matter which side of the fence the y is on. The only thing that matters is that the y is alone and that the y is positive, which we have. So there's a little trick. You can use it if you want to. You're always welcome, to do it the long way. If the long way makes sense to you, go for it. Do it the long way every time. But that's a little trick you can use. All right, we have this nasty thing here. Let's put it in slope-intercept form just so it's easier to graph. Remember, the whole idea is to get the y alone. So I want to get the y alone on that side of the fence. That's my whole goal. So let's get rid of some stuff here. I'm going to get rid of the 6 by minusing 6 from both sides. And if you want to speed this up a little bit, I want to get rid of the 2x as well. So I'm going to minus 2x from both sides as well. So what do I have now? My 6's are gone, my 2x's are gone. I have 3y. Now over here I have negative 6 minus 2x, but I would rather have the x come right after the equal sign. So I'm going to put my 2x here. But don't forget, there's a negative in front of that 2x. It's minus, but it's the same thing as negative. There's a negative in front of the 2x. So even though I want to shift the 2x over a little bit, that's fine as long as I take the negative with it. Same thing with the 6. That 6 is negative. Wherever that 6 goes, the negative goes with it. Alright, last step to get the y alone, I have to divide off that 3. So everybody gets 3 times smaller, or everybody gets divided by 3. My 3's gone. Y equals, now I'm going to write it like this, negative 2/3. And I'm going to put the x, instead of being up on top in the numerator, I'm going to put the x about halfway up. That's how we like to write it. So negative 2/3 x, and then a negative 6 divided by 3 is a negative 2. So I have y equals negative 2/3 x minus 2. All right. Think about what that line means. That's a downhill line, because my slope's negative. It's going downhill, and it crosses the y at negative 2. So it crosses at negative 2 and goes down 2 steps and right 3 steps. Alright, same problem. I'm just doing it using that little shortcut. Remember, if you jump a term across the fence, it changes sign. So same thing. I'm going to move the 6 to the other side of the fence, and I'm going to move the 2x to the other side of the fence. So I have 3y equals, I want my x term to come first, but remember, it jumped across the fence, so it became negative instead of positive. And then I want my 6 to come next. It was a positive 6, but it jumped across the fence, so now it's a negative 6. And the rest of the problem is the same. I don't have a shortcut for that. But anyway, some people like to just jump the terms across the fence and change the sign. It's just a little bit quicker sometimes. Alright, I'll work this a couple ways as well. Remember, we want to get the y alone, so let's get rid of, whoops, let's switch to black here. Let's get rid of the 3x. So I have 4y. Now this is a real common mistake. I'll put my negative 3x plus 8 over here. Remember, we want the x term to come right after the equal sign, and it's a negative 3x, and then the 8, and remember the 8's positive. Here's a real common mistake. You guys see what I did? I brought down the 4y, and I forgot the negative. Lots of people forget that. That's a real common mistake. Be careful. And then finally, divide by negative 4 and simplify. So y equals, now negative 3 over negative 4. A negative over a negative, that's really a positive. So I have a positive fraction, 3/4. Put the x about halfway up. And then positive 8 divided by negative 4 is a negative 2. So I have 3/4 x minus 2. There's my equation in slope-intercept form, and now it's ready to graph. Remember, that's a line that crosses the y-axis at negative 2, and my slope is positive, so it's going to go uphill. That's an uphill line that goes up 3 steps and 4 steps over. Okay, remember I said lots of people make a mistake. This is the same problem. Lots of people make a mistake because they forget that negative on the 4. Here's one way to avoid it. Anytime you see a negative y term, make that the first thing you get rid of. So I like to move the entire 4y over to the other side just so I don't have to deal with that negative y term. That's another way of working it. See, now we don't have to worry about forgetting that negative, because forgetting the negative is the most common mistake I see. And then just finish the problem. I would want a minus 8 from both sides. And so I have 3x minus 8 equals 4y, and the rest of the problem is exactly the same. And you have 3/4 x minus 2 equals y. Same thing. The y is on the right side, but that's okay. As long as it's alone and positive, we're good to go. And that thing's ready to graph. Okay, same problem one last time. And I'll just show you jumping the fence, alright? I'm going to jump the 4y over the fence, and it becomes a positive 4y. At the same time, I'm going to move the 8 to the left side of the fence, and it's going to become a negative 8, and my 3x comes down. Look how fast that is. So all I did was take the 4y over here, take the 8 over here, I changed their signs, and then all you have left to do is just divide by 4. Just a little quicker. You don't have to do it that way. It's just a little quicker. Same thing, 3 different ways.